In terms of transport options, we obviously should be moving away from the model in which we all drive onto a car, which is the least efficient transport technology that has ever been developed on this earth. Public transport is much more fuel efficient, and the bicycle is much more fuel efficient than public transport. In fact, a bicycle uses about 1/50th the energy per kilometre of a car with one person. And it's usually renewable energy like muesli rather than non-renewable energy like oil. So it's clearly the transport technology of the future. And I remind you that our attitude in Australia, where the bicycle is seen as something for young people until they can graduate to something more dangerous, is not a universal view. There are quite civilised cities in Western Europe where between 30 and 40% of all urban journeys are made by bicycle, because the structures provide a safe space that allow cycling, and urban planning means that more of the journeys that people make every day are within reach of an easy bike ride. And if we're serious about a sustainable future, we have to think about better urban planning. There are renewable fuels like ethanol and methanol, but they're limited in scope. I remember doing a back of the envelope sum nearly 30 years ago when people were talking about ethanol from sugarcane in Queensland, and I calculated that if we turned the entire Australian sugar crop into ethanol, it would produce about 10% of our transport fuel needs. So it could be a useful regional supplement, but it's not going to be a solution to the problem. And indeed, in the near term, it's more likely to be used to extend political careers than to extend fuel supplies. In the long term, the technical solution may be hydrogen, and it's possible in principle to use renewable energy to convert water into hydrogen and oxygen and use the hydrogen in fuel cells. That or solar electric are really the only potentially sustainable transport vectors. But the crucial point in transport is better urban planning to reduce the transport task. But this may be the vision of the future. Perth is one of 11 cities participating in a global trial of hydrogen fuel cell buses. Two obvious points. One is that it takes a lot of energy to split water into hydrogen and oxygen, so a hydrogen fuel cell vehicle will be much more expensive to run than those running on cheap petroleum, which I'd remind you, despite the harumping about the cost of fuel, still costs us less per litre than beer or cask wine or orange juice or milk or indeed bottled water. Tap water is about the only liquid you can buy in bulk if you pay less per litre for than you do for motor spirit. And given that it's a one-off geological endowment, that's probably criminally short-sighted. We should also recognise that there are potential environmental problems that we need to look at if we're thinking of using hydrogen as the transport vector of the future. One study published by two Caltech academics suggested that if hydrogen fuel cell vehicles replaced the present transport fleet, given that hydrogen is the smallest molecule there is and notoriously difficult to contain, we would probably lose about 60 million tonnes a year of molecular hydrogen into the atmosphere. Now the optimist would say that's all right, it will combine with oxygen and form water, so it will solve two problems at once. The pessimist in me says that may be true, but we've been wrong about atmospheric chemistry on a global scale before, and we probably should do the calculations before we release 60 million tonnes a year of molecular hydrogen, rather than finding, as we did with chlorofluorocarbons, there were problems we didn't know about. Let me move up in scale one level and remind you of the findings of the Millennium Assessment Report, which was set in train by the Secretary-General of the UN in 2000. It was prepared by 1,360 experts from 95 countries. It was the most comprehensive statement there has ever been of the condition of the planet. And its first finding was that in the last 50 years we've changed ecosystems more rapidly and extensively than any comparable period of time in human history, and that this has resulted in a substantial and largely reversible loss in the diversity of life on Earth. In terms of the unprecedented changes, more land was converted to crops in the last 50 years than in the 18th and 19th centuries combined. In the last 50 years, we've lost 20% of the world's coral reefs and degraded another 20%. We've lost a third of the mangroves. We've quadrupled the amount of water in reservoirs, as globally we have built large dams at the rate one every second day. The withdrawals from waterways has doubled, and so on. We've also massively interfered in the biogeochemical cycles. In the last 50 years, the flows of biologically available nitrogen have doubled, and the flows of phosphorus have tripled, as we've used artificial fertilisers to try and produce more food from a fixed land area to meet the needs of a growing population. In fact, humans now produce as much biologically available nitrogen as all the natural pathways put together, and this is likely to increase a further 65% by 2050. And the Millennium Assessment Report drew attention to the fact that climate change has been caused by a quite small human increment on the natural carbon cycle, and expressed surprise that we were as sanguine as we are about the massive increment of the natural nitrogen cycle that human activity is now causing, and warned that this may eventually be seen to be at least as serious a problem as climate change. In terms of the loss of species diversity, this is the distant past, the fossil record. Loss of extinctions per 1,000 species per millennium perhaps, because there's a certain amount by guess and by Gaia about some of these estimates. But we have a good record of the extinctions in the recent past of mammals, birds and amphibians. The crucial point is that it's somewhere between 100 and 1,000 times the long-term average of the planet's history. So we are now already in the middle of the 6th major extinction event in the history of the planet. We're losing species at rates comparable to that of the great extinction events at the end of the Cretaceous or the end of the Permian. But the gloomy bottom line is that none of the forces which are causing extinction of species, loss of habitat, introduced species, chemical pollution, none of those forces are slowing down, but they're now being supplemented by climate change. And the Millennium Assessment Report said, and this is the salmon pink line on the other side, the salmon pink line, that the predicted future extinction rate is somewhere between 10 and 100 times the current rate. And if that is true, we are likely to lose between 10 and 30% of all mammal, bird and amphibian species this century. In other words, we're facing not a minor decline in species, but a biodiversity catastrophe. I don't want to depress you, but there's some bad news, which is that the report went on to say that this is based on the traditional climate modelling, which assumes that we are modelling linear and reversible changes. But they said there's established but incomplete evidence that our impacts on ecosystems are increasing the likelihood of non-linear changes. In other words, that we could be pushing natural systems beyond some critical threshold where they change rapidly to a different stable state. And the Millennium Assessment Report quoted half a dozen examples of such changes in recent human history. The best known one is the Newfoundland cod fishery, which was harvested more or less sustainably for about 100 years, at about 250,000 tonnes a year, until technological advance made it possible to catch about 3 times as much fish. The fishery collapsed, there was a minor revival, but then it collapsed completely. It had passed a critical threshold and it moved to a different stable state in which that fishery was no longer accessible. And the Millennium Assessment Report warned that we are still cosmically ignorant of the complexity of the great natural systems of the planet, and we risk inadvertently pushing them past some critical threshold into a much worse situation. The good news is that the changes we've made to ecosystems in the last 50 years have not been done maliciously. They've actually been producing significant net gains in human well-being. In the last 50 years, as John Fuller reminded you, the population has doubled, but economic activity has increased by a factor of 6. So humans are on average 3 times as wealthy today as we were 50 years ago. Food production has actually increased by a factor of 2.5. So the world is producing more food per person today than ever before. A remarkable 2 kilograms of food per person per day. In round figures, the world produces each day for each person about 1 kilogram of fruit and vegetables, about half a kilogram of cereals and pulses, and about half a kilogram of protein. And it would take a pretty dedicated trencher person to get their mouth around 2 kilograms of food every day. So by reason of supply, there is no reason for anyone to go hungry. But the report warned these gains gains have been achieved at growing costs, and unless they're addressed, they will substantially diminish the benefit that future generations obtain from ecosystems.